All right, this is a review for the factoring unit in Intro to Algebra 1. So what we have in front of us right now is the factor tree. This factor tree, remember, you're going to always do your GCFs first. All right, after you do the greatest common factor, you're going to then determine how many terms are there. Are there 2 terms? Are there 3 terms? Or are there 4 terms? If there's 2 terms, you're going to do a difference of perfect squares. If there's 3 terms, you're going to do the trinomials. If there's 4 terms, you're going to do grouping. All right, so we'll come back to that. That's really for when you're doing complete factorization. All right, I'm going to do a couple examples of each one here. So first, we have the greatest common factor. So when you do greatest common factor, you're looking for a number and the letters that can be divided evenly into both of these. What do both of these have that I can take out? So 3 and 9, there's a 3. X squared and x, they both have an x, and there's x to the first that I can take out from both of them. And we have what's left over in parentheses with that minus sign coming down. Divide the 3's, get a 1. They had 2 x's, we took 1. They only have 1 x left over. 9 divided by 3 is a 3. They had an x, but we took it. So it's gone. That's my final answer. Number 2, same idea. 16, 4, and 8. There's 3 different sections we're looking at here. 16, 4, and 8, I can take out a 4. That's for the numbers. Now I have to look at the letters. So I have A's and B's. A's, I have 2, 1, and 5. So I can definitely take 1 from each. I only take 1 because this one only has 1. B's, I have 3, 2, and 5. So I can take 2 B's because this one only has 2. So that's what I'm going to take out. And then I have to figure out what I have left over. So I have this minus sign coming down, this plus sign. So I have these 3 different terms I need to divide now. So 16 divided by my 4 is 4. I had 2 A's, I took 1. So that leaves me with just 1 A there. I had 3 B's, I took 2. So that leaves me with 1 B. 4 divided by 4 gives me again a 1. They had an A, I took it out. They had 2 B's, I took them out. So there's only just a minus 1 there in the middle. So I'm actually just going to clean that up, make that look a little bit nicer. This is going to just be a minus 1. Now plus 8 divided by 4 is going to give me a 2. They had 5 A's, I took 1, so they still have 4 left over. And then B is they had 5 and I took 2, so now they have 3 left over. So that's it for the greatest common factor. But in factoring trinomials, you're looking for numbers that multiply to be the last term and combine together to be the middle term. So in this case, we have a 28. You have 1 times 28. You have 2 times 14. You have 4 times 7. So the first part is always going to have the x from the x squared, x times x. The 28, I need to have a 4 and a 7 is what I'm going to choose because that's the one I can get a 3 from. The last term here is a negative, which means these have to be different signs. All right, the bigger number always gets the middle sign right here. So this is going to be a minus, that's a plus. Double check yourself, 4 minus 7 is the negative 3, so that is correct. Number 2, same idea, we're going to factor this. The x's are again in the front to get you that x squared. The 10 is a 1 times 10 and 2 times 5. So one of those has to work or it doesn't factor. So the 2 times 5, that's going to be that 10. It also adds together to be the 7. Since this is the same, since this is a positive, these two have to be the same. They're going to be whatever the middle term is. That middle term has a big say into what these two are going to be. All right, factoring trinomials again. This time, well, what happens if you have a number out in front of that x squared? Now this is a little more difficult. So the trick I use is we're going to take that 2 and move it to the end. So this is x squared minus 5x minus 6. And then you're going to factor this just like we just did this last year. So 1 times 6, 2 times 3 can give me the 6. I need to figure out which one is going to give me the negative 5. So 2 plus 3 can give me the 5, but I need it to be a negative. Since this is a negative, I know I have to have 1 positive, 1 negative. So it's really going to be the 1 and the 6 that's going to work here. If you try 2 and 3, you just wouldn't get the correct answer in the middle. So since this is a negative, I need 1 positive, 1 negative. The bigger number, again, gets the middle sign. So this gets a negative. This is a positive. Now, I'm not finished yet, though. Remember, we changed the problem multiplying by 2. I have to undo that by dividing by that 2 now. This 2 doesn't divide evenly into the 1, so you bring it back out to the front, 2x plus 1. 2 does divide evenly into 6, so it's just x minus 3. And that's it. Number 4. I have a 9x squared minus 24x plus 16, so I'm going to do my 9 times by 16, just like I did number 3. This gives me x squared minus 24x plus 144. So I'm looking for numbers that multiply to be 144, and there's a whole slew of them. 1 times 144, 2 times 72, 3 times 36, I believe it is. No, that's not going to work out. 4 times by, I think it's 4 times 36, that's going to work out there. So 3 has to be something, it'll be, let's see, 40, I don't know, 48, I believe. 3 times 48. All right, 4 times 36. 5 doesn't work. All right, 6 is going to work. 6 is going to divide into that 24 times. 7 is not going to work. All right, 8 will work. All right, 8 is going to be 18. 9 is not going to work. 10 will not work. 11 doesn't work. 12 does work. 12 times 12. So I'm looking for numbers that are going to multiply together to be 144. We have those, and now add together to be 24. So when I go through and do that, I'm looking for what numbers I can get to 24. And if you look through the list, it's really going to be that 12 and 12. So this is going to be an x and a 12, an x and a 12. Again, since this last number is a positive, we need to make sure we have the same down here. They're both going to get that negative from the front. From here now, I have to divide by my 9. You notice we're going to get the same answer here since it's the same. This is a special trinomial. All right, and the 9 is not going to divide into that 12 evenly, but it will reduce by 3. So this is going to be x minus 4/3, as is the second one. And I'm going to then kick that 3 back out to the front to be 3x minus 4 and 3x minus 4. I'm going to rewrite this now to be 3x minus 4 all squared. Since there are 2 of those, we're going to put those together. All right, next difference of perfect squares. This one's a little bit easier to do because these are those simple ones where you're just literally looking for numbers that multiply to be 3 and add, multiply to be 9, which is going to be the 3 and 3, that add together to be 0. So this is x minus 3, x plus 3. And you're going to notice the pattern here. If I jump to number 2, this is going to be x minus 9, x plus 9. Number 3, you can't do this. All right, you cannot do this. This one is done. You can't factor that because this is a plus sign. Again, it has to be a difference. So it has to be a minus sign for perfect squares. Number 4, you're doing the same thing here. All right, sometimes people get confused. If you get confused, I would say just cover up this 4 right here. Look at x squared minus 21. You're going to have the x's and x's. 1 plus 1 minus 121. Take the square root, you get 11. Now what about 4? Square root of 4 is just 2. Just put that in the front. Number 5, you can do the same exact type of thing there. You have 49 x squared minus 100. That's going to be a 7 and a 7x for the 49 and the x squared. The 100 is going to be a 10 and a 10. And the one's going to be a plus, one's going to be a minus. So we don't write these as squares because the plus and minuses are different. So they are not the same as each other. All right, next type would be grouping. So in grouping, you're going to group the first 2 and the second 2, and you're going to look to see if there's anything that's similar there, looking for a greatest common factor. It's basically 2 greatest common factor problems all at once. So GCF of the first 2 is x squared. I'm left with x plus 1. Have to have a plus 1 there. Plus, GCF in the second one is a 3. You're left with, again, x plus 1. And if you notice here, you're left with the same thing on the inside, x plus 1s. All right, so you're going to factor that x plus 1 out. When you do that, they go away. And you're left with just what's on the outside, x squared and a plus 3. That's x squared plus 3. Second one here is a little more difficult because this is a minus. You have to be careful. We're going to make this a plus and a negative, and then I'm going to group this. So when I do that, this minus there is on the inside. Still a minus 4x. We'll just have it as a plus and negative 4x. Again, GCF in the first one is an x. We take it out, we have x plus 2. In the second one, we're going to take out a negative 4 this time. And that's going to be, again, an x plus 2. I'm taking out a negative because they both are negative. Again, notice, just like we did last time, that this x plus 2 is the same. So I can take that x plus 2 out. So this gives me x plus 2 out in front. And in the second set of parentheses, you have the x and the minus 4 that's left over from the previous step. All right, again, here's that factor tree again. All right, we're now going to look at some complete factorization problems. So GCF, you're going to go from here, and then you're going to enter the GCF, you're going to look to see, are there 2, 3, or 4 terms? Now remember, not every problem can be factored completely. Not every problem can be done multiple times. All right, but these 2 can. So I'm going to show you these 2 examples. So again, you look for a GCF first. Here I have a 3. I take it out, and I'm left with x squared minus 9. Now that has 2 terms. Now I'm going to be looking at difference of perfect squares. Well, the 2 terms here, this is going to be x minus 3x plus 3, just like that previous problem we had done. That is my final answer. A key here is you have to remember to bring down your greatest common factor and put it into the answer. A lot of times students will forget that. In number 2, you have a 2, a negative 8, and a 10. they all have a 2 in them. I can take that out. And you're left with x squared minus 4x minus 5. And now this problem, again, you have 3 terms, so you're going to try to factor this using those trinomials. So you have your group of 2 parentheses here. You have an x and an x in the front. I'm looking to get a 4 from numbers that multiply to be 5. Well, the only numbers that multiply to be 5 are 1 and 5 since it's prime. All right, so how can I get a 4? Again, I want this, since it's a negative, 1's got to be positive, 1's got to be negative. The bigger number down here gets the middle sign, so that's a minus, this is a plus, and that is your complete answer there.